Hello, my name is Peter Raymer, and today we're going to look at joins in Microsoft Dynamics 365 for finance and operations. You may have worked with joins in another language such as SQL. Joins allow you to combine data from two different tables into a single result set. So they're extremely powerful. Again, this lesson is to talk about joins, and you may have learned joins from using TSQL, or maybe you're new to joins altogether. Either way, I think it's really useful to look at TSQL, as that is the underlying language, and we're running a SQL database for Dynamics 365, and so understanding that code as well as the X++ code can be really helpful. So to start out, let's actually look at this Microsoft documentation on joins. Specifically in TSQL, there is inner joins, left outer joins, right outer joins, full outer joins, and even cross joins. In X++, there are similar joins, but they're named and labeled a little differently. So I want to show you those differences. Behind the scenes, TSQL is generated from that X++ code, but when we're writing X++, we need to know how to write it in the X++ language. So I'll get into the details of each of these joins a little later, and I've actually broke up this video into two videos. In this video, we're going to focus on the fundamentals of joins and inner joins, and then in the second video, I'll cover outer joins, exist joins, and non-exist joins. Okay. The second website that I'd like to show you is this W3 Schools website. If you've not checked out this website, it's really useful. It's got a lot of tutorials for learning different languages, including SQL. So I'm clicking on the SQL joins link, and it can explain what a join does. In this case, an inner join will return all records that have matches in both tables. So I really like to look at these Venn diagrams where we can see what an inner join looks like, and we can see that if I'm joining, say, a sales order table to a customer table, the system's only going to return records when I do an inner join when a record exists that has a match in both tables. You can see from these other joins that they work a little differently. An outer join will return all records from the first table regardless of whether there is a match in the second table you join. This is a left outer join. Right outer joins in TSQL are very similar to left outer joins. They're just backwards. So you actually don't see them very often. Usually developers will just switch table 2 to be table 1 and table 1 to be table 2. And then that will make it a left join, and that's usually a little bit more common and easier to read. Full outer join is going to include all records regardless of whether there's a match on both tables. Okay, so that's kind of the high level of TSQL explanation. Again, we're going to go into detail on each one of these so you can really understand. I definitely recommend playing around with this site and reading some of their explanations of SQL, as this is a complicated concept and will take you a while to play around and really learn it. And in regards to that, there is actually a try it yourself button on this website that you can click on, and it will actually open a little editor where you can change the SQL query that's right here in this top statement, and then you can click Run SQL, and it will actually show you the results of your SQL query. So this is really useful if you don't have a development environment set up. You can play with TSQL here, and then that'll help you as you're writing X++ queries. Okay, so let me close these couple tabs. I'm actually going to go back and show you the various queries in X++ because they're actually written a little differently than these few here. in X++, I'm actually going to bring up my blog site right here. There is a join statement. This is the same thing as an inner join or join in TSQL, where it combines and returns only records that match in both the first table you mentioned and the second table you're joining to. An outer join we kind of talked about as well, is essentially a left join in TSQL. So it'll include all the records in the left table, even if there's not a match in the right table. I'll double check and test this here in a little bit in our next article, but outer joins are essentially left outer joins in TSQL. Okay, next we have an exist join. Exist joins aren't actually a join in TSQL. Exist is a keyword, but it's really used in a where clause. In X++, we actually have it as a join type. But what it does is it's similar to a join, but the difference here is when you join the second table, it will only look to see if a single record exists. If it does, it will include the record in the first table. It will not increase the number of records in the result set. Again, I'll go into detail and show you a specific example. I just wanted to give you a real high-level description of this to start. A non-exist join, similarly, does not actually exist as a join in TSQL, but we have it in X++ as a join type. This will check to see if there is not a row in the second table we join, and if there's not, then it will include the first record. This is really useful in things like batch jobs or insert record sets where we're trying to create data where data is missing. This query can help find where the data is not there, and then we can have a while select loop or an insert record set to actually insert the data we're looking for. Okay, so let's go back to this join statement. Let me show you an X++ example. Before I do that, I'll pop up this image. This is my version of a Venn diagram. Similar as before, in X++, we just use the keyword join. We don't use the word inner. And this is going to return records when there's a match between the first table and the second table. And then the second key concept for you to really understand in this is that when you join one table to another, especially with a join statement, you can actually increase the number in your result set. And I'll show you that a little further on. But that's a key concept to understand, is joins are both about understanding when do we include records, but also that records in the result set can actually expand and be more than just the number of records we have in our first table. So let's look at some examples. So if I go to Visual Studio, I've gone ahead and created a project, and I've added a runnable class. You can add a runnable class by right-clicking on your project, say Add, New Item, and pick Runnable Class, parentheses job, give it a name. I name mine Join Types Tutorial. Okay, in this, you can put code directly in the main method. I went ahead and created two static methods that I can call just to show you each of these two examples a little bit more clearly. This is the first example we're going to look at, which is just a basic join. So pretend that you're looking at a sales order and you want to get information that's on the related customer record. We can actually look at, we declare a table buffer sales table and a table buffer cust table. We say select first only, which will grab us only the first record of each of these. We say sales table, where sales table dot sales ID equals a specific sales order number. I just looked up and found this sales order number in the USRT legal entity or company within D365 that comes on all of these Azure hosted development boxes. Then I'm going to say the keyword join, specify the table that I want to join to, in this case cust table, and then I need to say the relationship between these two, the two fields that have to have the same value in each of the columns in order for the system to kind of line these up and put them on the same row. In this case, account num on cust table is going to contain the same value as cust account on sales table. So I've specified my relationship. You might have more than one column that you need to match to make these tie together, or oftentimes you may only have one. So I've got one in this case because cust account uniquely identifies a record on cust table. I can actually know that by looking at some of these tables like cust table or sales table. If I look at the sales table, I actually don't see a cust table in the relations, but this is the relations is where you want to look to kind of understand the relationship between two tables. You may need to talk to the developer or look at the values themselves, but usually the best place to start is by looking at these relations and seeing if you can find a relationship. You won't always find a relation on these tables. So if I'm on cust table looking for, or on sales table looking for cust table, I didn't find one. If I'm on cust table looking for a sales table, you won't always find a relationship. So really understanding functionally how these tables works helps you understand what relationship you want to use. Also looking at the unique indexes on a table and understanding that, okay, here's the primary key. If I can find that this primary key is on another table or the same value, I can join on that match. So that definitely takes some figuring out. And looking at the relations is oftentimes your best friend for finding that out, but it doesn't always have the information we need. So moving back to this select statement, we're querying the sales order, we're joining to cust table, and what the system's going to actually do for us is load in the data of all the columns into a table buffer called sales table and load all the columns for cust table into a table buffer called cust table. So you might be used to using SQL where it's all just one long row. In X++, each of those fields are going to be stored in their associated table buffer. So if you have a whole bunch of joins, they'll each be in their own table buffer, which is actually really nice. So in this next line of code, we're going to check to see if the record was found. So I can say if table and cust table, if both of these are found, go ahead and print out a message. What this is doing behind the scenes is really just saying if sales table rec ID is not equal to 0. So the rec ID is a field that is on every X++ table, and it's always set to a non-zero value when we insert it by rule. And so by us checking to see if this table buffer has a rec ID set, that's a way we can see if a record was actually found. If it is set to 0, then that means no record was found in the database that meets this join criteria and where clause, and it'll go into our else statement. We can actually just write this a little bit more shortly by getting rid of the rec ID does not equal 0, because this is going to do the same thing behind the scenes. Okay, this info statement, we're going to print out sales order %1. %1 gets replaced by this first parameter, so the sales table sales ID was found with customer name %2. And here's where it gets really cool. So now that we've selected data into cust table, we could display values from columns on this cust table, but we can also run methods. So cust table actually has a method, if we look at it, named name. And it's going to run a bunch of code inside of name to be able to get to the name, maybe combine a first name and a last name. So we essentially have the power of a high-level language now that we've selected the data into these table buffers. So okay, in this case we use the select first only. I want to take a minute now to explain some of the differences between X++ and T-SQL, and then we'll look at a T-SQL example. In X++, we have first only, whereas in T-SQL you use the words top one to select only one record. In X++, you've got a where statement that can appear multiple times, each on every join, whereas in T-SQL you only have a where clause once after all of your joins. In X++, we use the name of the table buffer variable, not actually the name of the table, whereas in T-SQL you always use the name of the table, but you can also add like an alias for use kind of further down in your where or on clauses. In X++, we use 2 equal signs, whereas in T-SQL you'll use 1 equal sign. In X++, when we do a join, we use the keyword where again on every single one of our join clauses, whereas in T-SQL, your first relationship that you specify, you use the keyword on. And then lastly, we don't have it here, but in X++, you would either use and or ampersand if you're going to add another relationship or where condition, or you can use pipe for or. Whereas in X++ or in T-SQL, you're going to use the actual word and or. So let's go ahead and look over at that. If you go to SQL Server Management Studio, this is a fantastic tool for really investigating your code and your query. I often like to write the query here first and really understand what's going on. And then later I can copy that over to X++ and kind of translate it. The reason why I like to use this tool is you can really see the data quickly within this result set, especially if there's a lot of columns and a lot of records. So here's our first join statement that we already saw in X++, just rewritten in T-SQL. I'm selecting from sales table. I'm giving it an alias called ST. I'm joining cust table. I'm doing CT. And the other difference is in T-SQL, I need to join in the data area ID. There's a data area ID field that exists on most tables. Any tables that's company specific or legal entity specific. In T-SQL, I actually have to join this together and have a where clause that says what company am I looking in. Whereas in X++, this relationship and where clause is actually added for us by the kernel code when it generates the SQL. So that's really nice. But I can come in here. I can, when SQL Management Studio first opens, I can click OK. I can select this drop-down, AXDB, to select the correct database. I can click New Query to open a query window. I then can copy in this code, and then finally I can click the Execute button to run this code. So here we see that there's just one record. It does pull in our couple columns, and we're all set. If I wanted to see more columns, I can add a comma star, and I can see all the columns on sales table and cust table all together. Okay, let's look at one more example for joins. So I'm going to come back here. I'm actually not going to run this, but I'll comment this line out and then uncomment this join example multiple rows. And let's look at this one. This is similar, but a little different. Let's pretend that you have a sales order and you would like to see all the data from the sales order header, but also the data on each of the sales lines. We can do that by using a while select loop. In this case, functionally, we know we need a while select loop because there could be more than one sales line. There might be 0, there might be 1, but there could be more. And if there can be more than one sales line, we need to use a while select loop because we could get more than one result in our result set. And that's the other key piece that I want you to understand. When we join to a second table and we're doing an inner join, or a join in this case, the result set could be more than just what's in our initial table. So in this case, we've filtered our sales table to only be one record. There's only going to be one sales table record returned by this part of the query. But by us joining to sales line, if there's more than one sales line on the sales order, we'll actually get multiple results back. And in this case, there are 4 sales lines, so we're going to get 4 times through the loop. I can again print out the records using a string format and the info function, but this isn't always the easiest way to see the data. So let's look again at the data using SQL Server Management Studio. So I've gone ahead and recreated the same query using TSQL. I can join to sales line. I need to add in my data area ID and my where clause. I need to use a single equals sign, but then a lot of this is the same. And then when I run this, I actually get back all of my sales table records and sales line records. The sales table columns are going to be repeated each time, but the sales line values will change based on the data in each sales line. So this is just really useful to understand that when you do a join, you can get back multiple records. So I think that's the main thing that I wanted to show you so far in this course. Again, learning how to use joins are extremely powerful. Learning how to use SQL Management Studio to play around with your joins can be really effective versus just writing the queries in X++. Once you get them the way you want, you can bring them back into X++ and test them there as well. In the next video, I'll be showing you how to use outer joins and exist joins and not exist joins. Hopefully you've learned something new today. Thank you so much. I really appreciate you watching. If you liked the video, click the like button. I also invite you to push the subscribe button as well. If there's other topics you would like to see a video on, please post in the comments and I'll see what I can do. I hope you learned something new today. Thank you.